Okay, so yeah, this is one of those questions got a lot of calculus tricks in it, and I'll be honest with you, I sat through the walk me through it a couple of times to make sense of what they were talking about. So, but here's what I've come up with. So the first thing is that we want to get rid of that cosine. I mean, let's back up a little bit. If I substitute in 0, I get 1 minus 1 because the cosine of 0 is 1. And the sine, 6 times 0 is 0, and the sine of 0 is 0. So I get 0 over 0, tells me it's removable. You know, there's a hole in the graph here, so I can remove that discontinuity and figure out the limit. Okay, so how do I do that? Well, this is, like I said, this is one of those calculus trick problems. And they have these two, this is from the back of the textbook. It's also, if you go out to that SOS trig, or SOS Math with their trig formula, this is what I pointed my pre-calculus students to last semester, or actually I always pointed to when I teach pre-calc, but I know the people that are in this course that were with me last semester saw these forms. And what they say in the walk me through is they have this magic, what do they say? Then we know that cosine, how do they write this? They know that cosine U equals 1 minus it's 1 minus sine squared of U over 2, I believe is what they substitute in. Now that's right. So how do they do that is what I can't, this should be a squared, sorry, this should be sine squared. So how do they get that out of these two things? Well, not these two things. Out of either this one or this one. I mean, it's very tempting. It's very tempting to use that one because if I take the square root, I get cosine u, and then I can do that substitution. But I can't. I mean, how can I make that be equal to get rid of the cosine? You know, so it doesn't work well. So if you look at the other one, and I'm going to rewrite this trig identity a little bit. And I'm going to rewrite it as cosine, sorry. Let me back up a minute. Sine squared. So I'm going to write this as sine squared of u over 2. So now we're taking the half angle here, and then instead of writing 1 minus cosine 2 theta, I'm going to write, maybe I could just use this in terms of theta rather than u, since that's what we're dealing with here. Let me fix that. Cosine theta over 2, and cosine 1 minus the cosine of theta. See, so what I did is instead of writing 2u there, I'm saying it's equal to half of it. Same thing when we're doing those trig, those half angle identities. How do you find the angle, right? So it's like when you're trying to find the sine of 7 pi over 12. The one doing exact value. Well, you know that that's equal to u over 2, so 7 pi over 12, if I want to solve that for u, I'm going to get u equals 7 pi over 6, and that's one of the unit circle values. So that's if you remember, that's how that works. And if you don't remember, you can probably wing it and not worry too much about it. I mean, honestly, this is this kind of problem is the problem that's going to build muscle. It's getting the trick. If you're going to do Calc 2, yeah, you want to kind of think about it a bit. But if Calc 1's kind of the exit point, we can do Calc 1 without being able to do a problem like this. Let's see, where am I? So I'm at this, right? So over 2. So then what I'm going to do is I'm going to multiply everything by 2. So I get sine squared of theta over 2 equals 1 minus the cosine of theta. So now if I solve this for cosine theta, I'll add cosine to this side, I'll subtract that, and lo and behold, that's where they're getting saying that the cosine of theta equals 1 minus 2 sine squared of theta over 2. Okay, just so you know, that's where that's they magically appeared it, but that's where it came from. Okay. So let me do some erasing here. Let me pause the video and I'll come back. So I can't get rid of the back of the text without erasing more stuff, so I'm going to have to suffer with that. So what we're going to do is we're going to do this replacement. So 1 1 minus, I'm going to replace that cosine theta with that mess. So 1, notice my parentheses, it helps keep, make sure our signs don't change, or we keep their correct signs. That's a famous trick I have. Okay, so sine 6 theta, okay? And then if we distribute that negative through, the 1 and the negative 1 cancels out, and that negative 2 turns positive. So now I'm left with sine 2 sine squared of theta over 2. And that's over sine of 6 theta. Okay, step 1. So now what they have us do is what we want to get this denominator, the sines. I really would like to have this sine 6 theta to be sine 6 theta over 6 theta, because then when I say the limit as theta approaches 0, that turns to 1. Okay, that's what I want to do. Now let's see if I guess I got to erase this way. So what I'm going to do is I'm going to multiply that denominator, just the denominator, by 6 theta over 6 theta. Isn't that 1? So I'm not changing the value of this rational expression, or this fraction at all. Okay, so I can think of this now as 2 sine squared theta over 2 all over 6 theta sine of 6 theta all over 6 theta. Right, because remember this is over 1, so I can multiply. So we know we get a process of 6 theta on the bottom when we do the limit as x approaches 0, as theta approaches 0. So now I got to take care of the top. So I've got, and what they tell us to do is break that sine squared out into 2 sine theta over 2 times sine theta over 2, because that's where we're getting the squared from, right? And then we'll do the same thing with one of these expressions. So I'm going to multiply that 2's from that 2, and now I'm going to multiply by theta over 2 times theta over 2 times sine of theta over 2, right? Because that way this is 1. I got a form of 1 here, right? And so what does that give me? Let's see here. Can I move some stuff around here? Okay, so that's going to give me 2 times theta over 2 times the sine of theta over 2 over theta over 2, right? Because this is over 1. And then that 2 and that 2 cancel out because I'm be multiplying, right? So where am I at now? Okay, so I've got this. This needs to be theta, not 0. So then I see, if we just look at this expression, don't the thetas cancel out? So I'm left with 1/6, and that's just a multiple constant, so I'm just going to pull it right out of the mix. I'm going to pull it right out of that limit expression, because I know whatever this limit's equal to, I'm going to multiply it by 1/6. So it's theta equals 0. So I've got sine of theta over 2 over theta over 2 times the sine of theta over 2 all over 6. No, the 6 is gone. I took care of that. All over sine 6 theta over 6 theta. I'm running out of room on my screen. So now what we're going to do is we're going to take the limit of this expression, and this expression, because those limit laws say we can, when you're multiplying two limits, it's the product of the limits, and when you're dividing, it's the quotient of the limit, right? So this expression is that sine x over x. So this just turns into 1. We still have, and then we have the sine of 0 over 2. Notice, because I'm letting theta go to 0, right? And then the denominator is the sine of 6 theta over 6 theta, or sine of x over x, which is 1. And then we get that 1/6. So we've let the limit happen. We got 1/6 times that. Well, 1 times sine theta, sine of 0 over theta is the same thing as sine of 0 over 1, right? And sine, whoops, that's 0, not 1. It says 0, not theta. So sine of 0 is 0. So 1/6 times 0 is 0, and all that work just show that's equal to 0. But, what if it's something else? What if it's another expression? So I hope that helps. Maybe go back and try that. I hope I helped clarify the areas where we're confusing. Certainly made me think about it. So I'll come back and maybe I'll try the next question here.